Good morning. On behalf of the management of St. Joseph Engineering College and the Department of Computer Science and Engineering, SJEC, I extend a warm and hearty welcome to each one of you to the 5-day online faculty development program on emerging trends in artificial intelligence and data science. For today's forenoon session on time series analysis with demo, we are fortunate to have with us Dr. Siva Shankar, Assistant Professor, Department of Computer Science and Engineering, National Institute of Technology, Tiruchirappalli. Dr. Siva Shankar has been awarded PhD in Computer Science and Engineering by Manonmaniam Sundaranar University. Dr. Siva Shankar has 18 publications in international journals and 16 publications in international conferences. We are indeed honored to have you with us, sir. On behalf of management of St. Joseph Engineering College and the Department of Computer Science and Engineering, SJEC, I extend a warm and hearty welcome to you, dear sir. Before we proceed to today's session, here are a few guidelines for participants to keep in mind. You are requested to mute yourself during the session. We request all participants to ask questions only towards the end of the sessions. You may post questions in chat box to avoid congestion. We also request every participant to fill attendance form using the link shared in the chat box and WhatsApp by 4 p.m. This is to inform you that session would be recorded. Participants are required to take up a quiz at the end of the FDP covering questions from all the sessions. Without further delay, I now call upon Dr. Siva Shankar to take over the session. Over to you, sir.
Yeah. Okay, madam. Thank you. Thank you, madam, for the nice introduction. So in today's class, I will give you some input about time series analysis for business intelligence, right? So we'll study some problems about working with moving averages, autoregression, moving averages. We'll study something about recurrent neural networks, a brief intro about recurrent neural networks and so on. So I'll try to, I have some problems solved in solved for moving averages, weighted moving averages, autoregression. I will show you the solutions to the problem and how to solve the problem. To start with, what is data analytics? So data analytics is knowledge discovery in databases, right? So you have large volume of data. According to World Economic Forum report 2015, data is a new class of economic asset like currency and gold. So they compare data with currency and gold, and they say that data is a new class of economic asset like currency and gold. So data analytics is the science of examining raw data with the purpose of drawing conclusion about that information. So it is knowledge discovery in databases. It helps the industry to make better decision. It is classified into supervised learning, unsupervised learning, semi-supervised learning, and so on. So these are the major categories: supervised learning, semi-supervised learning, and unsupervised learning are the major categories in data analytics. I'll present an overview about the data analytics techniques, and then I will give more emphasis on time series analysis and the problems related to time series analysis. So basically analytics, we have different types of 4 major categories of algorithms in analytics: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So descriptive analytics helps us to summarize the data, like what's happening across the organization. It can be summarized using descriptive analytics. And diagnostic analytics, it helps you to uncover why some event has happened, why the profit has increased over a period of time, or why there is a decrease in sales over a period of time. It's known as diagnostic analytics. In the case of predictive analytics, based on the past data and current data, will predict the future data. So it's known as predictive analytics. We have regression, linear regression, multiple regression, logistic regression, even time series analysis can be used for, mostly they are used for predictive analytics and prescriptive analytics. So what should I do? So if I know something is likely to happen, what should I do? Like the price of gold is increasing for the past 6 months. So what should I do? I should invest in gold if I need more returns from my investment. It's known as prescriptive analytics. So these are the major categories of analytics. So you have descriptive analytics, summarize the data, find the mean, median, mode. So what's happening in an organization, you can identify using descriptive analytics. And if something happens, you can identify some outlier happens, you can identify by means of diagnostic analytics. So in the case of predictive analytics, based on the past data and current data, you can predict the future data. And finally, prescriptive analytics, what should I do if I know what is likely to happen? It's known as prescriptive analytics. So we'll study something about descriptive analytics. So classification is one form of supervised learning which maps data into predefined groups or classes. It is often referred to as supervised learning. So you have a training data set with class labels. Once you build a model using the training data set, given an unknown label, it should be able to predict the class label. So classification is an example of supervised learning technique. And we'll also study regression in time series analysis. Regression, we assume that the output variable fits into some known type of functions. So the output variable fits into some known type of functions, namely linear or logistic function, y equal to ax plus b, or y equal to a plus bx plus cx square, and so on. It's known as equation, linear equation. You are going to assume that the output fits into some linear or logistic equation. It's known as regression. So example of regression is like a manager wants to reach a certain level of savings before his retirement. Periodically, he predicts his retirement savings by current and several past values. He uses a simple linear regressive formula to predict the value of savings in future. So so based on your past savings and current savings, you can predict the savings at the end of 30 years using a simple linear regression formula. It's known as regression. So this topic we are going to discuss today in detail. Time series analysis. Here the value of an attribute is examined as it varies over a period of time, right? So we are going to examine the data as it varies over a period of daily basis, weekly basis, or monthly basis, and so on, right? It is used to determine the behavior of your product. So for example, in stock market, we used to analyze the value of stock prices as it varies over a period of time, maybe weekly basis, quarterly basis, monthly basis, or yearly basis. For example, a person wants to invest in a stock market. He charts the daily stock price of some blue chip companies he is likely to buy. He decides to buy a stock which is going to be less volatile and which gives huge returns over a period of time. It's known as time series analysis, right? So for example, we have some IT sector stocks like Infosys, TCS, which are blue chip companies, which delivers more than 20% returns for the past 10 to 15 years. We also have banking and financial companies like HDFC, State Bank of India, ICICI Bank, and so on, and some public sector enterprises like BHEL, Indian Oil Corporation, and so on. So a person wants to choose a list of stocks so that his returns will be more than 10% in a year. He used to daily chart the prices of stocks, and after 1 month of studying the data, he will choose to buy the stock which will give huge returns. Similarly, it should be less volatile. And next analytic task is like prediction. So in the case of prediction, based on the past values and current values, we will be predicting the future values. It's known as prediction. So in the case of descriptive data analytics, we have a technique called unsupervised learning. We have a technique called clustering. So clustering means we will be grouping similar objects together. So in the case of cluster, the objects will be similar within the class. So the objective of any clustering technique is to maximize the intra-class similarity and minimize the inter-class similarity. So the next analytic task in a data set can be association rule mining, which is used to identify relationship among data. So like it is used by retail sales community to identify the frequently purchased items together in a market basket, right? That's known as association rule mining. So similar to association rule mining, we have sequential rule mining, where an event occurs that triggers some other event over a period of time, right? For example, you buy a computer, you are likely to buy an internet connection within a short time. It's known as sequence discovery. And the next type of analytics technique that you can perform on data is data characterization. So data characterization is the summarization of the general characteristics or features of target class of data, right? So you have some target class, we have a class of data. You need to summarize the features of the particular class of data. It can be represented by bar chart, pie charts, right? So we need to study the characteristics of students who are studying in NIT Trichy. We can go for data characterization. So we need to study the profile of people who are buying Apple iPhone in India. We can go for data characterization. So similar to data characterization, we have another task called data discrimination. It is a comparison of general features of target class of data objects with general features of objects from one or more contrasting classes, right? So I need to compare two different objects in different classes. I can go for data discrimination. For example, we can compare the software general features of mobile phones or smartphones whose sales have increased 30% last year with the sales whose sales have decreased 10% in the previous year. We can go for data discrimination. So data discrimination means you can compare two set of contrasting classes, the general features of one class with the general features of objects in another class. So next, finally, we have outlier mining. So a database may contain some objects that do not comply with the general behavior of the data. So these data objects are called outliers. And most data mining techniques discard outliers as noise or exceptions. However, in some activities like fraud detection, the rarely occurring events are going to be more interesting than regularly occurring events, right? So in fraudulent activity detection, the rarely occurring events are more interesting than the regularly occurring events, and for this we go for outlier mining, right? So regarding the data that we work in time series analysis, we have different types of basically data in time series analysis. One is static data. So static data means they have zero temporality. Inferences that can be derived from this data are free from any temporality. So the normal data without any time stamp is known as static data. So it does not change over a period of time. So static data in the sense that the data remains constant and it does not change over a period of time. It's known as static data. And the next type of temporal data is sequences. Sequence or ordered sequence of events in a transaction, right? So you buy a computer, then you buy an internet connection, you buy a printer, right? It's an ordered sequence of events of transactions. So this type of temporal data have temporal relationship just as before, after, during, and overlap, etc. Then we have timestamp data. So timestamp data means that we are going to store data in a relational format along with a timestamp. For example, the stock price of a particular stock varies continuously throughout the day in a stock market. So we are going to store the stock price of the data with timestamp. It's known as timestamped data. And we have time series data. It's a special case of timestamp data. like where the events have some uniform distance on the time scale, right? So we are going to compute the sales of a particular product in a particular month, January, February. So I'm going to list the sales of a particular product month wise or year wise, consecutive year wise. It's known as time series data. So, and fully temporal data of this category is fully time dependent. The inference is also strictly temporal, right? So the applications of time series database are used in healthcare. So to analyze the patient health history, we need to go for time series databases. So insurance companies, they use time series databases to analyze the EMI that is being paid. Claims and accident histories are also being analyzed in time series databases. In financial management, for portfolio management, accounting, for stock market analysis and audit analysis, we go for time series analysis. And in HR, human resources, for personal management, we need to maintain the salary and history of the particular person over a period of time. Again, banking, we need to store the credit history of a particular client over a long period of time. In scheduling applications, so I need to know like whenever we book a airline or a car or hotel reservations, the information is stored in a time series format, and it can be used to later make some decision making. So many scientific applications like weather monitoring, chemical process monitoring also uses temporal databases or time series databases, right? So the components of time series databases are trend, cyclic, seasonal, and random. So whenever you have some time series databases, we need to look for this component. Trend, whether there's a positive trend or a negative trend, whether the sales is going to be linear or non-linear. Cyclic, you need to look for wave-like patterns in the data. It's known as cyclic. Seasonal are going to be short wave-like patterns, whereas cyclic or long wave-like patterns. So some data may also have randomness in the data. It's known as it is random data. So the time series data, the first type of time series data will have some trend component. So it's a long-term, relatively smooth pattern that usually persists for more than 1 year. So trend means it can be a positive trend or it can be a negative trend. So the sales in the first diagram, there is a downward trend. It's a downward trend, whereas the sales in the second graph is going to be an upward trend. So you have two types of trend. It can be either downward trend or it can be an upward trend. The trend can also be a linear or it can be a non-linear. So basically trend is a long-term, relatively smooth pattern that usually persists for more than 1 year. So the time interval can be plotted annually, quarterly, daily, or hourly. It's known as trend. So trend means you need to check for the sales with respect to time, which can be upward movement or it can be a downward movement. And the next time series component is going to be seasonal component. So seasonal component or short-term regular wave-like patterns. So there will be like a peak for some time, then gradually moves down, and again there will be increase in sales during a particular quarter or particular year. It's known as seasonal component. For example, like a monthly arrival of tourists in a particular town. Like if you take tourist places like Srinagar, Kashmir, like tourism, the peak season will be around March, April, May, June. Again, there will be some weak season over a period of time, and again people will come on November, December, January. There will be again a peak season. So this is going to be whenever you have some short-term regular wave-like patterns, we call it as seasonal component. So it appears in regular intervals wherein the frequency of occurrence is within a year or even a shorter, right? Even in sales, in a particular organization, they have some festival sales, like during Diwali, you have some festival sales. During Christmas, the sales increases, right? So in a year, they do have some, in any supermarket or in any textile showroom, they have some months during which sales is going to be seasonal, right? So school uniforms will be sold very common in the month of June, and similarly, like during festival season, you have increase in sales in textile supermarkets. So you can record this short wave-like patterns. So there will be initially it will be very low sales, then gradually it moves up, reaches the peak, and again it falls down. You have wave-like patterns. It's known as seasonal component in time series analysis. Then the other component is going to be cyclic component. So cyclic component or long-term wave-like patterns. It is often measured peak to peak sales or trough to trough sales. So it's like short-term wave-like components are known as seasonal components, and long-term wave-like patterns are known as cyclic components. And finally, you have a random component. So in data, you may also have unpredictable random values or residual fluctuation values. So due to random variations of nature, accidents or unusual events in your data, so this is known as random component. So these are the 4 components available in the time series databases. You have trend component. So trend is again for a period of 1 year to, it may vary from 1 year to 1 day. So we need to find a trend which may be like a upward movement or downward movement. And in the case of seasonal components, you have short wave-like patterns. It's known as seasonal component. If you have long-term wave-like patterns, we call it as cyclic components. And if the data is going to be purely random and you have residual fluctuations, we call it as random component, right? So this is a diagram of product demand over 4 years. So we have we have plotted the demand of a product for the past 4 years. So in this, if you look into it, there's a trend component. So the trend component is this, it's upward movement. So there is an increase in sales. So the trend is like upward movement. And you have also have seasonal peaks. So seasonal peaks, they indicate short-term wave-like patterns. You have seasonal peaks. And cyclic component, it's going to be long-term wave-like components. And there are some random variations also. So due to some government policies or due to some exception data, we also have some decrease in sales, right? So these are the 4 components of time series analysis. Right. So let me show you some problems, and then we'll move on to the other part of the discussion, right?
Sir, we are not able to hear you.
Madam, can you see the screen? Moving averages.
Yes. We are able to see the PPT on types of forecasts by time horizon.
Okay, madam. So I want to share you a screen on Excel sheet. I will share it and update you, madam. 2 minutes.
Fine, sir. Yes, sir.
Right. Can you see the screen?
Yes,
Excel
sir.
sheet?
We are able to see the Excel
Right.
sheet.
So the screen is about the first method in time series. We call it as moving averages. So moving averages method is used to predict the value of a stock price or sales over a period of time, right? So this is the first basic technique in time series analysis, right? So here we have the weekly sales of your product over a period of time. So first week the sales of the product is going to be 39 units. Second week the sales of the product is going to be 44 units. Third week it's going to be 40 units, and so on, right? So we are expected to predict the sales of the week 8. So to predict the sales of 8th week, we are going to go for a technique called simple moving averages. So in this case, we are going to use 3 months moving averages. So 3 months moving averages in the sense that you are going to take the sum of 3 months, previous 3 months, and find its average, right? So the sum of previous 3 months is going to be 39 plus 44 plus 40, and then average divided by 3, you get 41. So to compute the 3 months moving average for the 5th month, we are going to find the sum of sales in 2nd month, 3rd month, 4th month, and average it. We get it, the moving averages value for the 5th month. And for 6th month, for 6th month we can compute the sum of sales by computing the average of sales in 3rd, 4th, and 5th month. And similarly for finding sum of sales of 7th month, we are going to find the sum of sales in 4, 5, and 6th month, and this is going to be the predicted value, right? So similarly for 8th month, we are going to compute the sum of sales by finding the sum average values of 38 plus 43 plus 39 divided by 3. So this is how we predict 3 months moving average for a particular product sales, right? So once you compute we have different moving averages. You have you can go for 3 days moving averages, 5 days moving averages, or 7 days moving averages to predict the sales of your product. So once you compute the sales of the product, you can also compute the error. So error is the difference between the actual sales and the forecasted sales. So the actual sales was going to be 45, whereas the forecast value was going to be 41. So the error value is going to be 4. So we do have some metrics for checking we have some performance metrics in time series analysis. We have a mean absolute deviation and mean square error. So once you calculate the error, so the error is going to be the difference between the actual data and the forecasted data. So once you compute the forecast error, we'll be able to identify the mean absolute deviation. So mean absolute deviation is like you compute the absolute mean of error and average them. So here the absolute mean of error 4, 5. So the absolute value of 4 is going to be 4, and minus 5 is going to be plus 5. So we are going to find the absolute value of error and average them. We get absolute value of like you get absolute value of error, which is going to be mean absolute deviation, and mean square error is going to be, we need to square the error and average them. We get the mean square error. So this is how we calculate we predict the sales for a particular product for the week 8 using moving averages, right? So for the first 3, if it is 3 months, for the first 3 months we'll not predict. We'll use the past 3 values of sales past 3 weeks of sales in order to predict the sales of the 4th week, and for 5th week we'll be using the sales of the past sales of week 2, 3, 4 and so on. So for week 8 you can compute you can predict the sales based on the past values, like it's like a prediction based on the past values and current values. You can predict the future values. So for week 8 I'm going to predict based on the I'm going to find the sum of weekly sales of week 5, 6, 7 and average it. It's going to be week 8 sales. You can also compute the error associated with the sales, and you can normalize the data. So the error is computed as the difference between the actual sales and the forecast sales. So the actual sales was 45 for week 4 and forecasted sales was going to be 4. So the error value is going to be 4, right? So we find the answer. Once you calculate the error, we can find the mean absolute deviation. So mean absolute deviation is going to be the absolute value of an error. Averaging the absolute value of the error, we get the mean absolute deviation. And whenever you average the squared errors, then it's known as mean square error. So these are the metrics in moving averages, right? So it's quite easier to follow and understand. So if you have a very large data, you can extend it to 3 months, 3 days moving averages, 5 days moving averages, and 7 days moving averages, right? So next, let me show you again an example using auto regression. Right, so this is the second problem that I want to discuss with you. So in time series analysis we have auto regression. So in the case of auto regression, also based on the previous values of sales of your product, you'll be able to predict the sales for the next month or next year and so on. So for example, in this product, in this problem, the problem description is right. You have year-wise salary, right? So a person salary during the year 2000 is going to be 1.99 million. 2001 it's going to be 2.229 million and so on. So we are expected to predict the salary in 2011, right? So given some historical salary of a particular person, salary or sales of a particular product or service in million, you can compute it using auto regression. So here they are using a third order regressive model. They say that the alpha value should be less than 0.05. So basically they have gone for a third order auto regression, second order auto regression, and first order auto regression, and based on that we are going to predict the values. So let me show you how this works. So let me take the problem alone. Right, so this is the input that you are given. So you can generate auto regression till third order auto regression. So third order means you can look for historical data for the past 3 years, and based on the past 3 years information, you are going to predict the sales of 2011 using auto regression. So in Excel, you have a lot of facilities to implement auto regression, moving averages, regression, and so on. So let me show you how to implement auto regression using a simple Excel sheet. So this is going to be the year, and this is going to be the, let us assume that the y is going to be, the y value is going to be sales in millions of a particular product in different years. So 2000 the sales is going to be 1.9 million, 2001 it's going to be 2.29 million, and so on. So we are expected to predict the sales of a particular product in 2011 using the different auto regression techniques. First order auto regression, second order auto regression, third order auto regression, and so on, and find the value for 2011. So let me explain how to perform a third order auto regression first. So you can select these values. Right. So the year, it denotes X attribute, and the sales, it denotes the Y attribute. So let us go for a third order auto regression first. Right. So we assume that this you are expected to predict the sales Y. We assume that it's going to depend on the variables X1, X2, and X3. Right. So right. So you are expected to predict it for 2011. You are expected to predict the Y value based on the value of X1, X2, and X3. So in Excel, you have a data handling component, data analysis. You can choose regression. So here the Y value is going to be B column, and the X value is going to be X1, X2, X3 values is going to be from C37 to E44. So the confidence level is going to be 95%, right? And we are going to have the output range is going to be G37, right? So we are going to plot the values. So here we need to check for the p value. So they have given the auto regressive parameter alpha value is going to be 0.05. The p value is going to be 0.821. Right. So we are going to compare. So the p value is going to be 0.821, which is going to be very high than the alpha value 0.05. So we'll go for second order auto regression. So we'll rename it as third order auto regression. So in the case of second order auto regression, you have only these two. We assume that the Y value depends on only X1 and X2. So we are going to apply data analysis in Excel. So we'll be using regression. So the y value is going to be B19 to 27. Sorry, B19 to B27, and x value is going to be C19 to D27. So the confidence level is going to be 95%. Output range is going to be F. So again, now we are going to check the p value. So the p value here is going to be 0.397055, whereas the alpha value is going to be 0.05. So we'll move on to first order regression. So the first order auto regression in this case is similar to linear regression, right? So you have only two variables. So y depends on the output variable, y depends on the input variable x1, right? So we'll be choosing the data analysis component and use regression. So we'll be choosing regression. So the y value is going to be D18 to 27, and x1 value is going to be C18 to 27. The confidence level is going to be 95. So the output range is going to be right F18. We'll place it here, the results. So now if you look into the p value, it's going to be 4 zeros, then you have 1. So the p value is going to be, it's going to be less than the alpha value 0.05. So now we can assume that we can use this value for computing 2011, since the alpha value is going to be less than the, so the p value is going to be, since the p value is going to be less than the alpha value, p value is going to be 0.0001, which is going to be less than the alpha value 0.05. We can use it for calculating the value for 2011. So based on the intercept value and x variable and the previous value, will be able to calculate it. So 2011 value is going to be G34 plus G35 star B27. So we'll be calculating it using G34 plus G35 star B27. So the predicted sales in million units will be 3.32. So this is how this is first order autoregression. Right. So
sir, we
what's the
have
problem?
some background noise.
It's visible, madam?
Yes, it's visible, sir.
Let me explain this problem.
So there was some
Right,
background noise.
background sounds.
Yes, sir.
Hello.
Hello. Yes, all participants are muted, but then there was some background noise from your end, I think. It's audible, sir.
Right. This is how we work with third order regression, auto regression. Right. So this is what already I have worked in my Excel sheet. So the problem is simple. We'll be using a simple regression to predict the sales. So this can be a salary or it can be a sales in million. Right. I will give you some theoretical background about this model. So you have year-wise sales of a product in million units. So in the case of third order regression, what we do is that we calculate based on the past 3-year sales, right? So the Y value is going to be based on YT minus 1, YT minus 2 and YT minus 3. So I'm going to calculate the sales of current year based on the past 3 years. It's auto regression, third order auto regression. Whereas in the case of second order auto regression, if I'm going to compute the sales Y with respect to only past 2 years, it's known as second order auto regression. And in the case of first order auto regression, if I'm going to compute the sales of next year based on only one previous year, it's known as first order auto regression. Right. So what we do is that so initially we have X and Y value. We are going to find the value of YT minus 1, YT minus 2 and YT minus 3. So it's going to like the sales based on the previous 3 years in the case of third order regression. So just you need to copy this column and paste it one column down. You get the value for YT minus 1. Sorry. Right. So YT minus 1 is equivalent to x1 and YT minus 2 is equivalent to x2 in regression analysis, and YT minus 3 is equivalent to x3 in regression analysis. So once you have this data, you need to select the information which is completely available, right? So we have the information for all the 3 variables for the year 2003 to 2010. You are going to paste it, and using data analysis software, right, you are going to find the intercept intercept value as well as x1, x2 and x3 values. So this is going to be x1 value, this is going to be x2 value, and this is going to be x3 value, right? So regression, I'm going to use the regression tool in data analysis. I'm going to choose this value as y output variable, and the input variables are going to be x1, x2 and x3, and I'm going to perform data analysis, and I'm going to display it in a particular cell. I'm going to compare the alpha value with the p value. So the p value given in the problem is going to be, it should be less than 0.05. So my alpha value, as per auto regression, the alpha value given in this problem is like, I need an accuracy of 0.05. So I'm going to compare the alpha value with the p value. Since the p value is going to be greater than the alpha value, I go for second order auto regression. So second order auto regression means I'm going to predict the sales based on only the past 2 years, right? Third order auto regression, I'm going to predict the sales based on the past 3 years, whereas second order auto regression means I'm going to predict the sales based on only past 2 year sales, right? So this is going to be y, this is going to be yt minus 1, and this is going to be yt minus 2, and this is going to be x. So this can also be renamed as y x1 and x2 in the case of linear regression, right? So I'm going to take only this data for which I have the complete information, and I'm going to again choose data analysis tool in Excel. I'm going to mark the response variable, the output variable. This column is output variable, and x1, x2 are going to be the input variables, and based on that I'm going to calculate the p-value, and again I'm going to check the value of alpha. Again the p-value is going to be large compared to the alpha value. So what I do is that I go for first order auto regression. So first order auto regression, the same problem. I'm going to compute the sales only on past 1 year sales. So I'm going to use only the past yt minus 1 sales to predict the future sales. So this is going to be y, this is going to be yt minus 1. So based on this, I'm going to construct a linear regression formula, right? Once I am going to construct a linear regression formula, I'm going to use this variable as y, and this is going to be x1, and when I do analysis, I get the intercept value and x variable value. So the p-value associated here is going to be 0.001, which is well below the alpha value. So we conclude for this data, first order auto regression will give better results. So I'm going to compute the sales for the year 2011 as a function of f intercept and x1 variable. So the intercept value is going to be 0.441. So I have taken f45 plus f46, which is going to be the x1 variable, into the previous year sales. So the previous year sales is going to be 3.27. So it's going to be f45 plus so it's going to be f45 plus f46 into d38, and I get a result 3.32. So this is going to be the sales of the sales in million units for predicted for the year 2011 using auto regression, right? So I have shown you some Excel sheets for moving averages and auto regression. Now we'll see the theoretical background of this concept. So everything auto regression is done based on simple linear regression approach only. So I will teach you simple regression also in my slides. Right, so these are the different quantitative methods for forecasting in time series analysis. So we have 3 major components. One is naive method, the other is going to be moving averages, which may be a simple moving averages or weighted moving averages, and then we have exponential smoothing. So these are the basic techniques for computing forecasting in time series analysis. So naive method, it assumes that demand in next period is same as the demand in most recent period. So for example, if the sales of your particular product in May was 48 units, then we assume that the June sales is also likely to be 48 units. It is very simple and cost effective method, but it's not the correct way to predict the sales of a particular product, right? So naive method is very simple. So if the sales of a particular product is 48 units in the month of May, we assume that the next month also the sales is going to be likely the same. It's known as naive method. It doesn't take into account the other factors like festival sales or some dull period in a business, seasonal peaks or seasonal downs in a business. So the next approach is like moving averages. So where we are going to find the average of demand in previous n periods by n. So this is what we have discussed in the first Excel sheet, right? So in the case of n equal to 3 means I'm going to consider the sales of the past 3 months, and then I'm going to find the average. So the sum of the past 3 months is going to be 15, average is going to be 5. So I predict that the sales for the month 4 is going to be 5. It's known as simple moving averages. So moving averages, the formula is going to be summation of demand in previous n periods divided by n. So we can have moving averages for 3 months or 5 months or 7 months, right? So whatever data you want, you can make moving averages. Like just you need to find the average of past 3 months sales and predict it for the next month, or find the average of past 5 months sales and predict it for the next month, and so on. So for first 3 months we are going to use the past. For the 4th month we are going to use the past 3 months sales, and we are going to predict like the value of 4th month sales is going to be 5, right? So again for the next month we are going to calculate it like 4 plus 6 plus 5 is equal to 15 divided by 3. 15 we have the sales for month 4, right? The same thing. And now how to compute the sales for the month 5? It's going to be 6 plus 5 plus 3 divided by 3. So 11 plus 3, 14 divided by 3. So 14 divided by 3 is going to be 4.667. So this is known as simple moving average forecast. So I'm going to find the sum of sales in the past 3 months and average it by 3. It's known as moving averages. So a variation to this is going to be weighted moving averages. So it gives more emphasis on the recent data. So the weight decreases for older data. So I assume older values, the weightage given to the older data will be very less, and I give more weight towards the recent data. It's known as weighted moving average. So here we have weight for a period n into demand in period n divided by summation of weights. So for example, the same information, in this case I am going to assign the weight for the first month as 1, weight for second month as 2, and weight for the third month as 3. So it will be 3 into 5, 15, 2 into 6, 12, plus 1 into 4, 4. So it's going to be 15 plus 27 plus 31 divided by 6. So this is known as weighted moving averages. So I'm going to assign different weights for different months. It's known as weighted moving average. I'm going to assign a higher weight for the previous month, and I'm going to assign less weight for the historical data. So for first month I'm going to assign weight 1 alone. For second month I'm going to assign a weight of 2, and for third month I'm going to assign a weight of 3. It's known as weighted moving averages, right? Maybe for 5th month calculation, again it's going to be 1 into 6 plus 2 into 5 plus 3 into 3. So 6 plus 10 plus 9. So 1925 by 6 it's going to be, so the total weight is going to be 6, right? So 25 by 6 it's going to be 4.167. Here the weight is going to be 1, 2, 3 for the month 6. So 1 into 5, 2 into 6, 3 into 7. So 21 plus 27 plus 5, 32 by 6, I get 5.33. So this is known as weighted moving averages technique, which is an extension of moving average technique, where we are going to assign different weights to different months. And for the recent month, I am going to assign high weight, and for the past data, I am going to assign low weight. It's known as weighted moving average. Right. So we have a plot between the actual sales and demand and time, and the sales. If you have a small weight on recent data, the curve does not converges, whereas if I have more weight, if I assign more weight on the recent data, the actual sales converges with the predicted sales. So the next method we are going to use is exponential smoothing method. So here the weight declines exponentially, and most recent data weight most, right? Here the formula is like forecast value for time t plus 1 depends on the actual value at time t, and you have a smoothing constant alpha associated with it. So the forecast value depends on the actual value. Forecast value at time t plus 1 depends on the current value as well as actual value at time t. So again, we can work out this using a simple formula. So you want to forecast a product demand using exponential smoothing with alpha equal to 0.10. So suppose in the recent months 6, the forecast was 175 and the actual demand was 180. So you are expected to forecast the product sales for the month 7, 8, 9, 10 and so on. So the actual sales was going to be 180, whereas the forecasted value was going to be 175. So this is going to be forecast plus this alpha value into actual minus forecast value. So based on which we predict the forecast value for the month 7 will be 175.50, and 8 will be again it's going to be some actual value, like it's going to be forecasted value plus alpha multiplied by actual value minus forecasted value, you get some value. So this method is known as exponential smoothing, and this can be applied for forecasting. And as we have discussed in the moving averages itself, for error forecasting we have a mean absolute deviation and a mean square error. So in the case of mean absolute deviation, it's going to be the difference between the actual value and the predicted value by n. It's known as mean absolute deviation. This is going to be the square of errors, squared error, and average it. It's known as mean square error. So we also have another parameter called a mean absolute percentage error for forecasting the error. So let me skip something and so this is what you need to know, right? So basically the first method, like wherever you have some time series data, if it is white noise data, it means that it is purely random in nature. So if the data is going to be purely random in nature, it's known as white noise. Here epsilon t denotes a series that has zero mean and has a constant variance. So if you look into the data, if the data has zero mean means you have equal positive values and equal negative values, then automatically the mean is going to be 0. If the mean of the data set is 0 and the variance, constant variance is going to be 1 and so on, and it's an uncorrelated random variable. We call it as white noise data. So if a data is white noise data, it means that it cannot be used for forecasting. So whenever you have performed time series analysis, before performing time series analysis, you need to check for the data set. So if it is a white noise data in time series analysis means it has zero mean and the variance is going to be constant. So it means that it is purely random in nature, and you will not be able to use that white noise data for forecasting. So the scatter plot of white noise data will indicate no pattern, and hence forecasting the future value is not possible. So this is what we have discussed used in the problem 2, autoregressive model. So an autoregressive model is one in which the output yt depend only on its past values, yt minus 1, yt minus 2, yt minus 3, and so on. So the output of a particular month depends on the previous month's sales, right? So the sales of this month depends on the previous month's sales, yt minus 1, yt minus 2 means sale of past 2 months. So yt is going to be a function of yt minus 1, yt minus 2, yt minus 3, and you also have an error term epsilon t. So a common representation of an autoregressive model is model where it depends on p of its lost values, p of its past values called as ARP. So p value is important to determine whether it's going to be autoregression 0 or autoregression 1 or autoregression 2 or autoregression 3 and so on, and is represented as follow. So the output variable yt depends upon the variable b naught. B naught is going to be the intercept plus beta naught is going to be the intercept. Beta 1 yt y into y of t minus 1 plus beta 2 into y of t minus 2 plus beta 3 into y of t minus 3. So it extends till beta p of y of t minus p. So the p value is going to be important. Usually we go for 3 level of autoregression, like the output depends on maybe the past 3 values plus epsilon t, which is going to be an error model. So this is what initially we worked for our problem. We solved autoregression 3 model. So where we we explored whether the sales of a particular product depends on the sales of the past 3 months, yt minus 1, yt minus 2, and yt minus 3, where beta naught is going to be the intercept, and b1, beta 1, beta 2, and beta 3 are the variables associated with the variables. So that's known as AR3 model. So we find out the alpha value is going to be very small compared to the p value. Then we moved on to AR2 model, and finally we ended up in AR1 model, right? So I remember teaching you, right, y of t is equal to beta naught intercept value plus y of t minus beta 1 into y of t minus 1. It's known as AR1 model. So mostly we stop with AR3 model, since we assume that the stock price is dependent on the previous day and day before previous day. So we assume that maximum level is going to be 3. So in autoregression we start with maximum 3 levels, and then we move towards it's known as autoregressive model. And this is moving averages model we have seen in the first slide. So a moving average model is one where yt depends only on the random error terms, which follows a white noise process. So instead of yt minus 1, we have epsilon t. So yt is going to be a function of epsilon t minus 1, epsilon t minus 2, and epsilon t minus 3. So it's going to be a function of all the error values. So a common representation of moving average model is where it depends on q of its past values. So here we use we need to find the q of its past values by which we'll be able to optimally represent the model. So it's going to be yt is equal to beta naught plus epsilon t plus pi 1 of epsilon t minus 1, pi 2 of epsilon t minus 2, and so on. So the term epsilon t is used to denote the white noise. And the next model what we discuss, we are like the concept is auto regression moving averages ARMA model, which combines both the previous models, auto regression and moving averages model, and it is referred to as ARMA model, auto regression moving averages model, where we need to look for past values of P and Q values. So it depends on the the ARMA model depends on P of its past value and P of its past value of auto regression, and Q of past values on the white noise. Right, if you have ARMA 2, means this model depends on the past values yt minus 1, yt minus 2, and error terms epsilon t minus 1 and epsilon t minus 2. So this is how we represent the equation. We represent the auto regression moving averages, which is going to combine we are going to combine auto regression and moving averages model. So if you are going to have only two values, AR2, which means auto regression with P value 2 and moving averages with Q value equal to 2, will have only two variables. Yt depends on yt minus 1 and yt minus 2, and it depends on the error term epsilon t minus 1 and epsilon t minus 2. Right, so we have solved the problem auto regression even using regression analysis. So you need to know how to work with regression analysis. For example, you need to identify the relationship between two variables. One is called predictor variable, whose value is computed from the experiment, and the other is called response variable, whose value is going to be derived from the predictor variable. So in simple linear regression, we have y equal to ax plus b, where y is going to be the response variable and x is going to be the predictor variable, and a and b are the constants which are called coefficients. Right. So in simple linear regression, we have the equation of the form y equal to a plus bx. Here we have y equal to b plus wx, where b represents the intercept and w represents the slope of the line respectively. Right. So we can rewrite it as y equal to w0 plus w1x. So we can solve it using the method of least squares. So we can get the value of w1 by using the method of least squares. W1 is equal to summation of xi minus x bar into yi minus y bar divided by summation of xi minus x bar whole square. Right. Right. So again, the last problem, right, we have a person's years of experience. So x is a variable that denotes the years of experience of an employee, and salary y denotes the salary in $1,000. So a person with 3 years experience, his salary drawn is going to be $30,000, and a person with 8 years experience salary is around $57,000. So we are expected to predict the salary for a person with 10 years of experience. So you know how to compute x bar and y bar, right? Mean of x is going to be summation of x divided by n, and mean of y is going to be summation of y divided by n. You know the values of x bar, and you can compute the values of x bar and y bar. And to compute the w1 values, it's going to be summation of xi minus x bar into yi minus y bar divided by xi minus x bar whole square. Right. So xi minus x bar is going to be 3 minus 9.1, yi minus y bar is going to be 30 minus 55.4. The next value is going to be 8 minus 9.1, 57 minus 55.4, and so on. So xi minus x bar into yi, summation of xi minus x bar into yi minus y bar divided by square root of xi minus x bar whole square. You can get the value of w0. So once you get the value of w0, you'll be able to calculate the value of w1. So w0 is equal to y minus w1 into x. So once you have this equation, y is equal to 23.6 plus 3.5x, you get the values of w0 and w1. you can predict the salary for a college graduate with 10 years of experience. So I'm going to substitute 10 for X, and I'm going to predict that his salary will be around 58.6, which is going to be $58,600 and so on. So in the case of linear regression, we have one response variable. Y is going to be the response variable, and X is going to be the predictor variable, and A and B are the constants which are called the coefficients. It's known as simple linear regression, and we were using the same thing for calculating auto regression, right? So auto regression, we were using regression where the past yt minus 1, yt minus 2 are going to be the predictor variables, and yt is going to be the response variable. So the same thing you can implement it in R programming. Just you need to store the years of experience as a vector X, and Y is going to be a vector of salary in dollars. So relation, you have LM function Y tilde X, you can get the relationship, and it gives you the result. And the next case, in the case of single linear regression, you have one predictor variable and one response variable. But in multiple regression, we can have more than one predictor variable and one response variable. So you have one response variable, capital Y, and you have multiple predictor variables, X1 and X2, X3 and so on. It's known as multiple regression. So multiple regression also can be easily implemented using R programming. So I'll pause this presentation and you can execute this code. So you have a car data set, empty cars available in R programming environment. So it gives the comparison different car models in terms of mileage per gallon, cylinder displacement, horsepower, weight of the car are going to be the parameters. You are going to find the mileage with respect to the cylinder displacement, horsepower of the engine, and weight of the engine, weight of the car. It's known as multiple regression, right? So mileage per gallon, right? I am going to find the mileage of a particular engine based on the horsepower, displacement, and weight. It's known as multiple regression. And logistic regression, again, it can be used for classification where the response can be categorical value, where the output can be true or false. So this problems in R, if you run it, will it has a car data set, attributes like the same thing, horsepower, weight of the cylinder, and AM denotes whether it's going to be automatic or manual. So AM is going to be the class label, which is used to determine based on the cylinder, horsepower, and weight of the engine whether the car is going to be, the car engine is going to be automatic or manual. It's known as logistic regression, right? So I have added something about recurrent neural networks and basic introduction about LSTM also in the slide. So let me share this with your coordinator, and you will be able to get this. So this is a basic introduction to time series analysis. So hope at the end of this session you are familiar with the basic techniques like moving averages, weighted moving averages. You have exponential component in time series analysis, auto regression moving averages, and so on. So this auto regression component, they use linear regression and multiple regression for data analysis, right? That's the end of the session. Thank you for your patience listening. If you have any queries, you can
yes, sir. Sir, shall we start with the QA round, sir? We have some queries.
Right, madam.
Shall I? Okay, sir. So first question is, what is the difference between linear and first order auto regression?
Right. So in the case of, so we are using the same thing, first order auto regression also, it's going to be similar. We are going to use the linear regression concept for solving the first order auto regression. So first order auto regression, you have two parameters, X and Y. So Y is going to be the sales in unit of X is going to be the year, and Y is going to be the sales in units of a particular product or service. So in the first order autoregression, we are going to compute y from y of t minus 1. It's known as first order autoregression. The thing is that autoregression, we go for different levels of autoregression. We go for a single order autoregression, AR1, AR2, AR3. So in the case of AR1, it's going to be the current sales in this year for a product or service depends only on the previous year sales. It's known as AR1. Whereas in the case of AR2, the sales of a product or service in this year depends on the past sales in the past 2 years. It's known as AR2. Then it becomes multiple regression, right? Whereas AR3, the sales of a product in this year depends on the past 3 year sales. It's known as third order autoregression. So we are using the autoregression. We are going to use the linear regression component for solving this autoregression problem. So whereas autoregression can be either first order autoregression, it's a linear regression, second order and third order autoregression, or usually it uses multiple regression concepts.
So next question is, how do we decide which order autoregression to be applied for which case?
Right. So the value of p, as I was giving it was given in the problem itself. P value is equal to 0.05. Usually they give the value of p, ARP. So basically computing p is based on a correlation between the two variables. So based on the value of p alone, we'll be going for to check whether it's going to be a first order, second order, or third order autoregression. Generally, we restrict to 3 orders for autoregression. If the p value is going to be less than the alpha value, autoregression variable given, then we'll stop with that. So in our case, the alpha value was going to be 0.05, and the p value we computed in first order autoregression was around 0.000, 4 zeros followed by 1. So we stopped. So based on the value of p, so p is going to be the past how many based on accuracy, based on the p value, we determine whether it's going to be first order or second order or third order autoregression. So this autoregression variable is given, value is given in the problem itself.
Okay, sir. So next question, for COVID new case prediction, which algorithm or model is good?
Can you repeat it, madam? For?
Yes, sir. For COVID new case prediction,
right, madam.
Which algorithm or model is good?
Madam, nowadays we do have state-of-art techniques like recurrent neural networks or LSTM, long short-term memory. So it all depends on the data set. When the data set is very large, we can go for even deep learning techniques for prediction. So I have not come across the data set, I have not looked into it. For a simple stock market prediction, weather forecasting, we do go for this conventional techniques like moving averages, auto-regression, moving averages nowadays. But we have evolved onto even some state-of-art techniques where we have more volume of data, streaming data like recurrent neural networks and so on. So even I heard something about RNN, but it's in time series analysis, I thought that let me start from the basics and move on towards the deep learning concepts. It's difficult to visualize RNN without knowing the basics of auto-regressions or auto-regression moving averages. This I'm not sure, but what I feel is that now a lot of state-of-art techniques are available for analyzing stream data and a large volume of data.
The next question, is alpha value given for time series prediction?
Yes, madam. So I have taken this problem from your textbook. The alpha value was given, and based on that, we were working on it. So the alpha value is given for time series analysis.
Participants, any other questions, you can post it in the chat box. If there are any more questions, you please post it in the chat box. Thank you, sir, for an insightful session on time series analysis. It was indeed an honor for us to have as resource person for today's session. Thank you participants for being an actively participating audience.
Thank you, madam. Thank you for the support and patience listening to the participants. Thank you, sir.